Source transformation technique. Reduce the given network into single voltage source using source transformation technique. So here you can see just convert this is a practical current source. It is an ideal voltage source. It is a practical current source. It is an ideal current source. Okay, ideal means no parallel resistance. For a current voltage source, there is no series resistance. This is practical current source. This is also practical current. So convert this one to voltage source. Convert this one to voltage source so that you'll get voltage source value. Voltage source values. These three voltage sources are in series. We can add it. After that, convert that one into current source because I have to add with another current value here. And finally, you can obtain single voltage source because the aim is what? Reduce the given network to single voltage source. To obtain the single voltage source, I'm converting the first one into voltage source. So V is equal to IR, Ohm's law. V is equal to IR. I is equal to 5. R is equal to 5. 5 into 5 is 25. And arrow mark side plus. Arrow mark side plus. And same value of resistance you have to connect it in series. Similarly, for this, 10 into 2 is 20 volts. And arrow mark side is plus. This is downwards now. Arrow mark side is plus. So 10 into 2 is 20 volts. So I'm going to convert this 10 volts you have to retain as it is. This I'm converting into voltage source. This I'm converting into voltage source. So 5 into 5 is 20 volts. Arrow mark side plus. Same resistance you have to connect it in series. Here 10 into 2. 10 into 2 is 20 volts. Arrow mark side plus. Same 10 you have to connect it in series. Now these three voltages are in series. In series we can add voltage. So plus 25. This is minus plus. Which one is greater? It is not matching. Plus minus. Plus minus means we can add both. But here it is plus minus, but it is minus plus. Which one is greater? 25 is greater. So 25 greater means you have to retain 25 direction plus minus here because in 25 volts above is plus. So same plus above is here and you have to subtract this 25 minus 20 is out 5 and 5 plus 10 is also matching with this plus minus plus minus plus minus plus minus. These two are same. I can add this 25 plus 10 is 35. 25 plus 10 is 35. That's why I have to maintain that polarity. And out of that, you have to subtract minus 20 from this because it is opposite polarity. So we'll get 15 and these 5 and 10 are in series. 5 ohms and 10 ohms are in series. So 15. Now again, if there is a voltage source and if it is a current source, okay, then in order to reduce this type of circuit, okay, here I cannot convert it into voltage source because there is no parallel resistance. There is no parallel resistance for this, but this I can convert it into current source because there is a resistance. I can convert this practical voltage source into current source where uh, V is equal to IR, I is equal to V by R. V is 15, R is 15. So 15 by 15 is 1 amps and direction of the current will be upwards minus 2 plus and same 15 ohm you have to connect it in parallel. So 15 by 15 arrow mark is upwards and same 15 ohm you have to connect here. Now I can add this 1 amp and 2 amps. 1 amp is going upwards, 1 amp is going upwards and 2 amps is going downwards. So between A and B nodes, 1 amp going upwards, this is coming down. So you have to retain the maximum value direction which is downwards and net current is 2 minus 1. You have to subtract if two currents are opposite, you have to subtract, retain the direction of maximum. So 2 minus 1 is 1 and 15 is there. So now the aim is what? You have to convert given network into single voltage source. Convert the given network into single voltage source. So this is not the final answer. Again, we need to convert this one back to the voltage source. So V is equal to IR 1 into 15. 1 into 15 is 15 volts and arrow mark side plus. Arrow mark side plus. So arrow mark is here downwards. Here plus this is minus. So that is at the terminal A side we have negative. At the B side we have positive. And same 15 ohm to connected in series. So this is the required answer. So this will be asked for 6 marks or at least 5 marks. So let us go to the second problem. For the network shown, use source transformation and technique and convert it into represent in a single voltage source. So it is current source. So you can see this is a what this there is a current source in parallel with this. So this one is one practical current source. This is ideal current source. This is also practical current source. This is practical voltage source. This is ideal current source. Okay. So we need to convert this. We need to convert this one to. You can see here in parallel we can add currents. No, I can convert this one to current source. I can convert this one to current source so that I'll get one more current and one more resistance here. Okay. This one is already current source is there. These two are in parallel. So 2 amps and 2 ohms. And if I convert this one, very first step, I am converting this voltage source into current source. So 4 by 2, 4 by 2 is 2, and arrow mark side, plus side towards plus arrow mark should be there. So downwards 4 by 2 is 2 amps and 2 ohms, and in these two are in parallel. Already it is not a voltage source, already it is a resistance. So these two are in parallel, 2 ohms and 2 ohms are parallel. It is 1 ohm. 2 into 2 divided by 2 plus 2 is equal to 1 ohm and 1 amp. And now this current 2 amps is going upwards, 2 amp is coming downwards, and 2 ohms are in parallel. 2 ohms parallel is 1 ohm. Okay, it is 1 ohm, and net current 2 amps going upwards, 2 amps going down. 2 minus 2 is 0. So you can write 0 current here. Net current is 0. 0 current means actually it is infinity open circuit. We can write it is open circuit. We can just ignore this and we can consider this 2 and 2 are in parallel. Now 2 in parallel is 1 ohm. Now this side we have 1 and 1 amp, and this also you have to convert into voltage source. This I'm converting into voltage source. 1 ohm into 1 amp. 1 V is equal to IR. I into R is 1 volts. Arrow mark side plus, and same 1 ohm you have to connect in series here. Between this and this, same 1 ohm is connected in series. This is 1 volts. And this is 0 amps means it is open circuit. So you can just remove it. And this is 1 ohm in series. After that, this 1 ohm and this ohm are in series. So you'll have 2 ohms. You have 2 ohms, and this is 1 volt. After that, between this node, this is entire is 1 node. Okay, because no other elements are there. So 3 amp is going upwards, 5 amp is coming downwards. So net current is downwards only. 5 is greater, no? So net current is, you have to write 5 minus 2 downwards. 5 minus 2 downwards. And only in parallel, we can add the currents. So you have to convert again this, you have to convert this into current source. So this is V is equal to IR, I is equal to V by R. So this is V is 1 by 2. 1 by 2 is zero point 0.5, and arrow mark side plus. Arrow mark side plus, towards plus arrow mark. So zero point 0.5 is going upwards, 2 amps is coming downwards, and same 2 ohm you have to connect parallel. If I convert into current source, same 2 ohm is connected in parallel. So 2 amps down, zero point 0.5 upwards. So net current is 1.5 down. Net current is 1.5 down, and again finally you convert this one to voltage source. So 1.5 V is equal to IR. 1.5 into 2 is 3 volts, and same 2 ohms you have to connect here, and this is terminal A, and this is B. So towards A minus should be there, towards B plus should be there. So we converted this complex network. We converted this complex network using source transformation we converted into simple voltage source, practical voltage source with 3 volts with internal resistance of 2 ohms. They repeated sometimes this is asked. So this one is most important. This one is most important. Sometimes you can see the previous question paper. This is also asked one time.